Hi, today we're going to solve a really interesting problem in motion in one dimension. This is problem number 17 in chapter 1 from the book Problems in General Physics by Irodov. The problem reads as follows. From point A located on a highway, one has to get by car as soon as possible to point B located in the field at a distance L from the highway. It is known that the car moves in the field n times slower than on the highway. At what distance from the point D one must turn off the highway? If you're familiar with Snell's law and its applications in different media, this problem can be solved without any calculus. But when I first solved it, I was not familiar with Snell's law and had to proceed with the traditional method. We will first look at the latter. Going from point A on the highway to a point C, the velocity of the vehicle is n times slower than it is in the field. And so, the time taken to reach point C, assuming that we get off the highway at some point at a distance x from D is, and the time taken to reach point B after getting off the highway is, the total time of the journey is then. Now, in order to minimize the time taken by the vehicle to reach point B, we must minimize the overall time of the journey. This is where the calculus kicks in. So far, we have only used geometry to arrive at the expression for time. So after taking the first derivative of the expression for time with respect to the variable x and equating it to 0, we get that the minimum value of x such that the time of the journey is minimized is as follows. So far, so good. But for a physicist, this is where the integration of Snell's law comes in. For a light beam traveling from one medium to another medium, both of different optical densities or refractive indices, the velocity of light is different in both media. Specifically, the ratios of sine to the velocity of beam of light in a media is always a constant. This is the official statement of Snell's law. Using Snell's law in the problem at hand, we can assume that the vehicle is a beam of light traveling from a denser optical medium to a rarer optical medium. Now, if the refractive indices of both media were the same, the shortest path between A and B would be a straight line. But since both mediums have different optical densities based on our assumption, the path is no longer a straight line. Now, applying Snell's law to a beam of light emerging from point A and going into the medium of higher speed, we see that the sign of incidence at the interface is 1. This is so because the angle of incidence is 90 degrees. Furthermore, the ratios of sine to the velocity in both media are constant. And we know that the speed of light in medium 1, that is, the highway, is n times lower than it is in medium 2, that is, the field. Using geometry, we see that the sine of theta 2 is x divided by square root of x square plus L square. And when we solve the previous equation relating the sine of theta 2 to n, by substituting the value of sine of theta 2, we get the following. And this concludes our solution to this very amazing problem. I would really appreciate if you could share this video with your friends and colleagues if you liked it. And I will see you next time. Until then, take care, have a great day.